Today we're going to find properties from a graph in a story, still focusing on rate of change and the starting point. So on a graph, your rate of change is going to be, if it's a straight line, this is what we're talking about because we're going to focus on straight lines today, it'll be the vertical change. And we know that on a graph, the vertical change is the change in y over the horizontal change. Which we know to be the change in x. Make sure when you're doing this, we don't want to forget the sign. So it's either going to be a positive graph or a negative graph. We'll talk about which is which, but don't forget the sign. The starting point for a graph will be where x equals 0, and because of that, it's going to be where the line, I'll say where the graph crosses the y-axis, and this is where x is equal to 0, because on the y-axis x is equal to 0. So the same thing we've been saying for equations and tables, it just looks a little bit different on a graph where x equals 0. Okay, now for a story or a word problem. This should sound familiar. We've talked about this before. The thing that happens over and over every time, adding or subtracting the same amount every time, that is your rate of change. And then your starting point or your starting amount will be what happens once. Or what you start with. When we look at rate of change, we want to look for words like per, every, each, etc. What happens once or what we start with might be something like a fee or a one-time cost or just how much we begin with. So start with this one. You're taking a photo shoot. The photographer charges a hiring fee of $75. That's probably important. And then $25 for every hour. So there's some of those keywords we looked at. Fee, every. So the fee is going to happen one time, the $75. So that is my starting point or my thing that happens once. And remember, we can write that as a point, 0.75, because it's at 0 hours. This is 0 hours. And then the rate of change will be the every, because it's happening, we're adding $25 to our total cost every hour. So this is $25 per hour. So if we wanted to write an equation for this one, it would be y is equal to 75 plus 25x. So we're seeing the same thing as yesterday. The thing that happens over and over, your rate of change, goes in front of the x, and then the thing that happens once, or your starting point, is by itself. It's that number by itself. Next problem, we have a lacrosse team that needs to buy new pads. The total cost is $2,300. That's the total, so it's not a starting point or a rate of change. So we're going to keep going. They've already raised $1,600. The lacrosse team will be selling pizza slices for $3 to raise the rest of the funds. So pizza slices for $3. Okay. if I look at the key words here, I have that this one is already raised, which means that they have started with $1,600. So my starting point is $1,600. Remember, we can write that as a point. So if we were to graph this, it would be the point 0, 1,600, because it's at 0 slices of pizza. For the rate of change, we know that pizza slices is going to happen more than once. It's going to happen hopefully lots of times because they've got a lot of money to raise. And so the pizza slices would probably be like my key here, because I know pizza slices is going to happen more than once. So it's happening over and over. We're adding $3 to how much we have. So my rate of change is $3 per slice. Now we're going to talk about how to find rate of change on a graph. We are going to first, since today we already have our 2 points on a graph, and I will do that for you on your homework as well. First thing we're going to do is draw a right triangle just like we did with Pythagorean theorem. A right triangle between the 2 points. So it's going to look something like this. And then you're going to have a right triangle like that. Okay, the second thing we'll do is count the squares for the vertical up and down, and then horizontal, and we are going to write it in a fraction. It's going to be the vertical, which is this way, over the horizontal, which is the same thing we talked about yesterday, the change in y over the change in x. How are x and y is changing. So we count the squares and we're going to write it in a fraction just like yesterday. The last thing we need to do is add the sign. So if it looks like this, if it's going up to the right, that is a positive graph. If it's going down to the right, that is a negative graph. Please make sure you write this down so you have it as a reference. We want our rate of change and starting point from this first graph. So we already have our 2 points plotted for you, and I will do that for you in this unit. We're going to make a right triangle out of those 2 points. So go directly down, vertical, and then directly over, horizontal. So you see a triangle here outlined in red. Now we're going to count, just like we did for Pythagorean theorem. Count the squares vertically. That's 1, 2. And horizontally, 1, 2, 3. Remember, you need to count not on the inside but the outside, because we're counting from this corner to the other corner. How far? How long is that line? So 2 and 3. I'm going to write this in a fraction. It's the vertical change, which would be 2, over the horizontal change. 3, change in y over change in x. But this is a negative line because it's going down. You could think of a dude like skiing down a mountain. Okay? It's a negative line. It's going down. Now my starting point, like we said on the front, is where the line crosses the y-axis. So my starting point is right here. And that is the point. It's always 0 first, where x is equal to 0, 2. Because that's what we call that point on a graph. So it crosses the y-axis at 2, and then it goes down 2, right 3, over and over and over. Next one, we'll start by finding our rate of change. I'm going to draw my right triangle between my 2 points. You can draw it either direction. I'm going to do it on the right side of the line this time. Doesn't matter, you could do it on the left side, you get the same thing. Let's count. The horizontal length is 1. The vertical length is 1, 2, 3, 4. You should label that. It's written as a fraction. Vertical change would be 4 up and down over the horizontal change, 1. This is a positive line because if you were to like think of a guy skiing from left to right, he would have to be going up, 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 up. So this is a positive 4 over 1. We can divide this evenly. It's going to end up being just 4. But if you leave it as a fraction, that's good with me. Now the starting point is where the line crosses the y-axis. Remember, your y-axis is this one. So the line crosses the y-axis right there. That's your starting point. I know it doesn't look like it, but that's what we call it. We call that the y-intercept. So that point right there, actually, by coincidence, again, is 0, 2. Because it's 2 squares up and it's at the x equals 0 axis. Okay. Last one. We're going to make a right triangle out of our points and find the distance. So 1, 2 for the vertical distance and 1 for the horizontal distance. So the rate of change is vertical 2 over horizontal, left and right. This is a positive line because if you were to think of like walking up this hill, you'd be walking up from left to right. So it's positive 2 over 1, which we could just write as 2. And the starting point looks like it's right up here. That's where it crosses the y-axis. And that is at 1, 2, 3, 4, 5, 6, 7. If for some reason the line, you can't see where it crosses the y-axis, you can like extend the graph and try and figure out where it would be by using the same rate of change because it will keep going right 1 up 2, right 1 up 2. So my starting point is at 7. We write that as a point, 0, 7.